Here I am going to consider six examples of six polynomials. Now I am going to discuss the zeros of this polynomial and their relationship with the coefficients of these polynomials which I have taken here. Now we can see some examples on zeros and coefficients, and these examples I am taking 6 examples, and now I am discussing the zeros of these polynomials and their relations with the coefficient of the polynomial. Now we can see one example I would like to consider. Third example I would like to consider. Px is equal to 6x square minus 3 minus 7x. It is not in standard form, therefore I am going to write down this as in the standard form, that is 6x square minus 7x minus 3 here. Here a equal to 6, b equal to minus 7, and c is equal to minus 3. And now by factorization method you can have this px is equal to, by factoring this one, that is going to be 2x minus 3 into 3x plus 1. Therefore 3 by 2 and minus 1 by 3 are zeros of px. Now let us verify whether these two numbers are what you can say zeros of px or not. You can say p of 3 by 2 is equal to 6 into 3 by 2 whole square minus 7 into 3 by 2 minus 3, that is going to be, what is going to be 6 into 9 by 4 minus 21 by 2 minus 3, that is going to be 3 into 9 by 2 minus 21 by 2 minus 3. This is a 27 by 2 minus 21 by 2 minus 3, that is 6 by 2 minus 3, that is 3 minus 3, 0. And also p of minus 1 by 3, which you can write down 6 into minus 1 by 3 whole square minus 7 into minus 1 by 3 minus 3, that is 6 into 1 by 9 minus plus 7 by 3 minus 3, that is going to be 6 by, this means 2 by 3, 6 3s are 2, 3, 2 by 3 plus 7 by 3 minus 3, that is going to be 9 by 3 minus 3, and that is 3 minus 3 is equal to 0. Therefore 3 by 2 and minus 1 by 3 are zeros of zeros. Now here and now we can see the relation between these zeros and the coefficients of the polynomial. Now you can see, therefore alpha equal to 3 by 2 and beta is equal to minus 1 by 3. Therefore, alpha plus beta is equal to 3 by 2 minus 1 by 3, that is 6, and this is 9 minus 2, that is 7 by 6. Now observe, this is going to be minus of minus 7 by 6. That is nothing but what you can say, minus b by a. This holds good. And next, alpha into beta is equal to 3 by 2 into minus 1 by 3, that is going to be minus 1 by 2, and this is minus 1 by 2. Minus 1 by 2 means that is c by a. C is what is that? Minus 3, and a is 6. That itself gives minus 1 by 2, and hence it is a relationship very well established. Now I am going to consider fifth example, pt equal to t square minus 15. Now you can see this has what you can say, the middle term is absent, and that is I can write down this is equal to t square a into t square plus b into t plus c. Therefore, here a is equal to 1, b is equal to 0, and c is equal to minus 15. So it is in the standard form, and roots of this can be written as a pt equal to t minus root 15 into t plus root 15. You can verify the factors here. Therefore, root 15 and minus root 15 are zeros. And now you can see here p of root 15 equal to root 15 raised to 2 minus 15, that is 15 minus 15 is equal to 0. Similarly, p of minus root 15 is equal to 0. Therefore, this root 15 and minus root 15, root 15 and minus root 15 are zeros. Now alpha equal to root 15 and beta is equal to minus root 15. I can write down, and therefore alpha plus beta is equal to root 15 minus root 15 is equal to 0, and 0, that is absent, that is 0 by minus 0 by 1, that is itself is a 0, that is minus b by a. I can write down very well, and alpha into beta is equal to root 15 into minus root 15, that is going to be minus root 15 whole square, that is minus 50, that is c by a, that will hold good. In this way, we can establish the what is that relation between zeros and coefficients of the quadratic polynomials.